Hi, I'm John Peterson, faculty in the Department of Physics and Astronomy at Purdue. I'm interested in galaxies, clusters of galaxies, structures of the universe, and cosmology. And JWST will potentially make a number of measurements in these topics in the early universe. Um, the combination of its large mirror and its infrared sensitivity and the fact that it's a space-based telescope um, will potentially make a number of groundbreaking discoveries in these topics. To prepare for JWST, my group and a set of collaborators have written a code called the Photon Simulator, or PhoSim. And this code simulates light through telescopes one photon at a time. And we do this in order to understand the exact observational complications and distortions to images that you might see. So in the following movie, you'll see the thermal distortion of the hexagonal segmented mirrors. You can see this in the upper right part of the movie. And then you'll see the photons coming from a distant star starting in the upper left panel. The color of those photons has to do with the wavelength of light. Then you'll see the photons being reflected off the primary and secondary mirrors in the upper right panel. And then in the lower left, you can see the photons slowly working their way through the NIRCam instrument through its lenses, mirrors, and filters. In the bottom middle panel, you can see those same photons being converted into electrons in the detector, and then the electrons drift towards the readout. And then if you look at the bottom right panel, you'll see the photons being collected into pixels, just like JWST will do. So in this way, you can see the full details of an image, just a single star. And JWST will potentially detect millions of these stars and galaxies in exactly this way.